Okay, this is 8-3, similarity between polygons. We are going to walk you through this lesson, but before we get to that, we're going to talk about some proportions. These are considered proportions right here, and hopefully you can all remember that we cross multiply on these. So what you're going to do is you're going to multiply 4 times 3, and you're going to set that equal to 8 times x. So we have 12 equals 8x. We divide by 8, and x is equal to 4 goes into 12 3 times, and 4 goes into 8 twice. So it's equal to 3 halves or 1.5, whichever you want to do there. So any kind of a proportion, that's how you'll set it up. You'd go 12 times 5 equals 3 times x. And you would set that up and go ahead and solve it. So we're not going to do any more of these, but I just wanted you to be aware of how to solve that. We're going to use that in today's lesson. However, we're going to have, let's see, if you have problems like this, you would still multiply. You'd have to put your parentheses here and make sure you distribute it. So you'd have -7 times 4 minus x equals 12 times 3. So you have to distribute that to both terms and then go ahead and solve. Okay. So that's just solving a proportion. We're going to use that in today's homework. 2 things that you should be able to get out of today is you can find corresponding lengths, perimeters, and areas of similar polygons. We're talking about triangles, pentagon, hexagon, whatever we have. And then also, by the end of today's lesson, you should be able to decide if polygons are similar. The symbol for similar is a squiggly line like that. So I could say triangle ABC is similar to triangle DEF, and that's the symbol that we use for similar. Okay? So looking first at the core concept here, we have 2 triangles here. We have triangle ABC, and then we have triangle DEF. Notice as we're labeling sides here, we go from the angle to the opposite side. The angles are represented in uppercase letters. The sides are represented in lowercase letters. And we can match up corresponding angles. If we're looking at this, angle A corresponds to angle D. So A is congruent to angle D. We look at this, angle B is congruent to angle E. So we have angle B, which is congruent to angle E here. B is to E. And then our last one, we have angle C is congruent to angle F. So those are the corresponding angles that are congruent. And we can also match up the ratios of the corresponding side lengths. So when we're doing that, I want you to notice what I'm doing here. We can take DE right there, and we can put it over AB. So the order that they are written in the similarity statement. So DE is to AB. Okay? And then I can erase that, and I can say EF. So EF is the second 2 letters, is to BC. And then I take the outsides, FD, so F and D is corresponding to CA. And that's how you'll set up your ratios. So if you have the similarity statement, you can tell what angles are congruent, and you can also tell, not sure, let's see, 1 second there. You really don't need that, but I'll leave it right there. So you can tell from this similarity statement right here, you can tell the angles that are congruent by the order, and then you can also tell the sides that are proportional. So let's go ahead and try that on an example here. This example right here, okay? And we're saying that triangle ABC is similar to triangle DEF. So because of the way that that is written, you can write down your angles that are congruent. So we can say angle A is congruent to angle D. Okay. Now I think it's important that when you draw the pictures here that you also indicate that in your triangles. So we just put 1 line there, meaning angle 1. Then we can also write down, we can say angle B is congruent to angle E. Okay? So I'm going to use green there, so B is to angle E. And my last angle is angle C is congruent to angle F. And we'll get rid of these red there. Okay. Now, so that takes care of the angles. In similar polygons, angles have to be congruent. If angles aren't congruent in similar polygons, then they're not similar. So now we can match up the corresponding sides. And I'm just going to use them in the order that they are there. So I would say AB is to DE. And they're not equal. Well, the ratio should be equal. Then I can go BC is to EF, and then AC is to DF. And that's how you can set up your ratios. So when it asks you for the angles and the ratios, then you can set them up like so. This is also, these are also going to equal K, which is the what? Hopefully you remember that from the first lesson, but that is the scale factor of the similar polygons. And one other thing well, we'll get to that in just a minute here. So looking at this, in the diagram, they want you to find the scale factor from the two triangles. So that's basically like finding the ratio. So in this case, we could go 12 is to, well, they want RST, so RST is to XYZ. So my scale factor would be 20 over 12, which simplifies if you divide top and bottom by 4, 5/3. Okay, so 1 2/3 or 1.67, whatever you want to do there. So that would be my scale factor. They want you to list all the pairs of congruent angles, and we'll just do this quickly here. Angle R is to angle X. Angle S is congruent to angle Y, and angle T is congruent to angle Z. So there's my angles. So that's part B, and then C, write the ratios that are corresponding side lengths in the statement of proportionality. Okay, so I guess we can write RS is to XY, ST is to YZ, and RT is to XZ. And if I were to plug in one of these ratios, if I went RS over XY, it would, just like I did, any one of these ratios should have the ratio of 5 to 3. So 25 over 15 or 30 over 18, those should also have the same ratio. Okay. Moving on, it says in the diagram, here's your similar triangles. Find the scale factor of JKL to PQR. It's important that you look at the order. So they want JKL to PQR. So JKL would be 6 over PQ. So my scale factor would be 6 over 9 or 2/3. List all the pairs of corresponding angles and write the ratios of corresponding sides. We did that on the last one. We're not going to do that on this one. But my scale factor would be 2/3. Okay. Corresponding lengths in similar polygons. If two polygons are similar, then the ratio of the two corresponding lengths of the polygons is equal to the scale factor. That's just what we proved in that last slide right here. Here's our ratio. We simplified it. It's the same as our scale factor. So it's 2/3 of the shape. And that's what this core concept is stating here. So in the diagram, here's our two similar triangles. Find the value of X. So here's where we're going to set up our proportions. So I know that EF is going to correspond to NP. So I'm going to go X over 30, and then I just need to set up another proportion as 15 is to 18. So what I want you to realize is you can match up based on the similarity statement, or Or you can look at it like this. Notice that both things that I have on top are from the same triangle, and both things that are on the bottom are from the same triangle. That's another way of looking at that. How would I solve this? I would cross multiply. So I'd have 18 times x equals 15 times 30. And let me do that real quick on my calculator. 15 times 30 divided by 18. It's going to give me an answer of 25, so x is equal to 25. Okay, so that's how you can find a missing value there. Doing the same thing here. Find the length of the altitude, ps. So they want you to find this value right there. We're going to call that x. So you can set this up the same. If I asked you what 6 corresponded to, and you could use either 6, but in this case, those are both 8. So 6 is to 8 as x is to 20. Solve it the same. 8 times x equals 20 times 6, which is 120. And we divide by 8. And x is equal to 15. Yeah, it's 15. So x is equal to 15. Okay. And then I would also, it's probably a good thing to look at it and say, does 15 sound like a decent number? If you were to get something that was larger than this one, then that would not make sense. Look at your answer and make sure it makes sense. Okay, find the value of x here. So we just need to match up corresponding sides. Notice we have our similarity statement, which can help you match up sides that are congruent or not. So in this case, I can say x is to 4 as 12 is to 6. And so we have 4 times 12 equals 6 times x. So we have 48 is equal to 6x. So we divide by 6. And x is equal to 8. Okay. Looking at this particular problem here, they want you to find km. So they want you to find this here in the blue. So we can call that x, if you will. So x is to 35 as 48 is to 40. And we're not going to cross multiply and you get 40x is equal to 48 times 35. You can do that problem in your calculator and come up with the answer. It's one that's not too tough. Now, along with sides and angles being congruent, sides being proportionate, the perimeters are also proportionate. So this is representing, if you were to add up all the blue perimeter or side lengths and all the red side lengths, that would give you the perimeter. You can break these apart and you can say that the ratio is the same, or the scale factor is the same from a side length as it is to the perimeter. So you can compare the side lengths to the overall perimeter, and that should be the same. So we're looking at it. Here's a problem that's talking about a swimming pool. Here's our original swimming pool, and it has a side length of 50 and a width length of 25. And they want to build another swimming pool that will have a length of 40 meters. So it's actually going to be smaller. So it's going to be inside of this pool. It's going to be a little bit smaller. And they're going to call our length 40. And it says find the perimeter of an Olympic pool and the new pool. So the perimeter here, if we just move these, you can see that our perimeter is 150. And the length of our new pool is 40. So we want to find the perimeter of the new pool. So you can solve that once again by cross multiplying and dividing. And when you do that, you get x is equal to 120, which is the perimeter of the new pool. If you wanted to find the width, you could just plug in an x there. Instead of x over 150, you could go x over 25 is equal to 40 over 50. And solve it that way, and that would give you the width of the new pool. Okay. Let's look at this. We're comparing perimeters once again, just like we did. We have two gazebos here shown in similar pentagons. Find the perimeter of gazebo A. So if we add up all these perimeters, 15, 9, 12, 15, and 18, it gives you 69. And this perimeter, we want to find this side, and we're missing this right here. But if we're trying to find the perimeter, it really doesn't matter what x is, because we can compare the perimeters like we mentioned. We know that 10 corresponds to 15, and we add these up in our perimeter there, 69. We're looking for the perimeter of gazebo A. And so if we just cross multiply and divide here, we get 15, we'll just call it P, equals 690. And we divide by 15. And the perimeter of the smaller gazebo is going to be 46. Okay. Which seems reasonable. The perimeter of the bigger one was 69, so being 46 is a little bit smaller, which is 2/3 of 15, so 10 is to 15. So that's how you can set that up and solve those. Okay, the last thing we're going to talk about is areas. And areas compare just as perimeters do, just as side lengths do. We take our ratio and we square it, because area is squared. So you can square those ratios and use that to help you find the side length, or you can take the side lengths and use that to help you find an area. So anywhere where it says theorem or it says core concept or something, that might be something that you want to jot down on a note sheet so you can use it later on in the chapter as well. So I'm looking at this here, and they gave you the area of ABC. So we have the area of this one is 36 centimeters squared. Okay. We do know that 5 corresponds to 10. So 5 over 10 is 1/2. So we take 1/2 and we square it, and we set it equal to the perimeter that we're trying to find. So this is the perimeter of triangle DEF. So we have x over 36, because we don't know what this perimeter is here. So we can call that x. This one is 36. So we have 1/2 squared. 1 squared is 1. 2 squared is 4. So when you have that squared, you have to do it to both the top and the bottom. So that gives us 1/4 squared equals x over 36. And we can cross multiply. So 4x is equal to 36. So x is equal to 9. So the area of this one is going to be 9 centimeters squared. And this one is 36, which makes sense. It's not, it doesn't correspond directly to the side lengths, but it is proportionate as the area is squared. We're going to give you a couple of these to try on your homework, but let's try one more here. We have 2 rectangles. They said the area of this one is 84. They want you to find the area of this one. So we can go 7 over 21, which is 1/3, as I've written right out here. 7 over 21, 1/3, and square it. So 1 squared is 1, 3 squared is 9. And then we take the 84 and put it over x, because we're looking for the area of this. So this is the smaller rectangle over the bigger rectangle. So we have 1/9 84 over x. So we have x is equal to whatever 9 times 84 is. And 756. So it's quite a bit bigger, meters squared. And that's how you find the area there. And then similar polygons, this is just to kind of wrap things up. It says to prove that 2 polygons are similar, you must show that they have corresponding angles. Remember, the corresponding angles need to be congruent, and the corresponding sides are proportionate. Okay, that means that the scale factor needs to be the same. So the scale factor needs to be the same on the sides, and you can set those ratios up and solve those. Hopefully that helps. Now you can go to the Big Ideas online book and check out your assignment. There's also example videos there. If there's problems that you're not sure how to do, click on the example videos, and that can take you to those and give you a little bit of an idea of how to do the assignment. Hope that helps, and we'll see you next time.
Let's see, I don't know. I got to remember where it goes to save it to your desktop here though, because we're gonna need that in a minute. So, sorry, I had to go get water. All of a sudden I had a cough and I was just like, ah.
Oh, that was you that left and came
Yeah.
back. Oh, I
Yeah,
didn't
that was
know.
me.
I didn't even know.
It was me.
Okay,
It's
so
like,
we
oh.
click right here.